Hey everybody, this is a little lesson here to help you out with solving stoichiometry problems that involve gases that are not at STP. We remember that if a gas is at STP, we can always use, the fact that 1 mole of gas is equal to 22.4 liters, but that is only at STP. What do you do if your gas involved in your chemical reaction is not at STP? You can't use this. You then need to go back and use some of the gas laws that you've just learned this week. So I'm just going to do 2 sample problems just to give you some examples, and you'll come across a few of these in the web assigns that you're going to be doing. So if you have a question like this, and I'll give you just a second to read it. You always want to check and make sure that the reaction is balanced. If you check this one, it does happen to be balanced already. And you want to look at the conditions. The pressure is not standard pressure. The temperature is not standard pressure, or excuse me, temperature. So we cannot use the 1 mole equals 22.4 liters when we're solving this stoichiometry problem. You just start it like a typical stoichiometry. You have 759 kilograms of zinc. That's, your reactant right there. So you'd start with your 759 kilograms of zinc and set up your factors. We know that a kilogram is 1,000 grams, or 10 to the third grams. And zinc is 65.39 grams per mole. So, your first job is always take your starting reactant and get it into moles. Then we always need our mole to mole ratio. This one's pretty easy since it's 1-to-1. We know that a mole of zinc produces 1 mole of the hydrogen gas. Now, if this had been at, standard, then we could have, tacked on that step. 1 mole of hydrogen is 22.4 liters and found the volume of the hydrogen. But this is not STP, so instead we have to solve this and find out how many moles of hydrogen we have. So, plug this in your calculator. And I got, and I'm going to keep 3 sig figs. I got 1.16 times 10 to the third. And I want to check that because I'm kind of sometimes hitting wrong buttons on the calculators before we move on. And that's, yep, I thought I remembered that. I must have not hit quite enough zeros. I did these problems earlier. And glad I double checked that because it was times 10 to the 4th moles of hydrogen gas. So we've got this many moles of hydrogen gas. So we know moles, we know pressure, we know temperature. That leaves us with just one variable in PV equals nRT. Remember, this is the ideal gas law. And so, if you look at this, we know pressure, we know temperature, we know moles because we just solved for it, and we know R because that is a constant, and the only one then that is left is, the volume. To solve for volume, we just have to divide both sides by the pressure. So the volume that's occupied by the gas is going to be nRT divided by P. We just solved for the moles. Okay. So we know how many moles of gas. One of the ways that people sometimes do this wrong on WebAssign is they'll just take this, this original amount and convert from, grams to moles, and they'll stop here. But look, that's moles of a solid. Zinc is a solid. You have to convert into the moles of the gas. Now, this happens to be a 1-to-1 ratio, but a lot of them in, WebAssign, they are not. So make sure you get moles of the gas because you're looking for the volume of the gas. And then we need the value of R, 0.082057, and that is liters, atmospheres over mole Kelvin. So our temperature, which comes next, has to be put into Kelvin. So we add 273 to the 22 to get 295 Kelvin. And we divide all of that by the pressure, which is already in atmospheres. If it was not, we would need to, convert that into atmospheres. You can use your unrounded number from the first part, especially if you're doing WebAssign. I think, it's preferable. Or I'm just using the rounded number here because I'm starting over. So multiplying the top three numbers, dividing by that pressure, and let me see. Once again, I think I hit the wrong button. I apologize. And dividing by the pressure. And I want to put this in scientific notation because it is a big number. And let me see. I do still need 3 sig figs. My answer, the volume, is going to be equal to 2.55 times 10 to the 5th. And unit-wise, if you take a look at, the units, the moles divides out, the Kelvin divides out, the atmospheres divides out, and you are indeed left with a unit of liters, which is a volume unit. Okay, so sometimes you have to do a stoichiometry problem first to get moles, and then use the moles of gas in a gas law problem to get the volume. Or like if you knew the volume, maybe you would need to use the moles and the volume and the temperature to find the pressure or something. They sometimes in WebAssign, they mix up which variable you're looking for. So the other way that you sometimes can combine gas law problems with stoichiometry is that you maybe will have to do the gas law problem first and then the stoichiometry. Like if you read this problem, okay, they know everything about this gas. They know here's the volume, so they know volume. Here's the pressure, so they know pressure. Here's the temperature, they know temperature. You can use pressure, volume, and temperature to find the moles of gas. And then if you look at the problem, it's asking you to calculate the mass of the KClO3. Once you, calculate the moles of the gas, then you can do a stoichiometry to get the grams of, the solid. So I'm just going to make a little space for myself here, take some of this stuff away. Hopefully you noticed about this problem, one thing is that you do need to balance this. And so we need a 2, 2, 3 to balance this decomposition. So we're going to start out with the gas law. And remember, we're trying to calculate moles. We have PV equals nRT. To calculate moles, we've got to divide both sides by RT. So the moles of oxygen will be equal to the pressure, volume over RT. Everything needs to be in the proper units. So I'm going to convert my millimeters of mercury. And and remember, I'm using rounded numbers. WebAssign will kind of like you to keep a couple extras probably. But that is 975 divided by 760. The volume, the 50 milliliters, I need to divide by 1,000 milliliters in a liter. So there's my volume in liters, or multiply by 0.001 liters for every individual milliliter. On the bottom, R is a constant. And that's liter atmosphere per mole Kelvin. Oh, no, I don't want to end the show. I just need to make that mole Kelvin. And what else do we need on the bottom? Temperature. We've got to add the 273 to the 45, and we get 318 Kelvin. Remember, you always got to have these units matching up. You can see our atmospheres divide out, our Kelvin divides out, our liters divide out, and we're left with 1 over moles, which is, that's the same as moles. So we will have the moles of gas. So 1.28 multiplied by the volume divided by R divided by the temperature. And I got, let me see, how many sig figs do I need? Yeah, 3. 2.45. The answer is 2.45 times 10 to the negative third moles, and that's the gas, so that's oxygen. Okay, and that's important because if we don't know which one it is in the balanced chemical equation, then we might get the mole-mole ratio wrong. So we are eventually trying to calculate the mass of the KClO3, but we are starting with moles of oxygen. So we do need to do the mole-to-mole ratio. This is the step that a lot of times people will miss on WebAssign or like a quiz or a test. They'll find moles and then they'll just convert moles to grams, but this is moles of oxygen and we're trying to find the mass of KClO3. So we do need to use that 3:2 ratio. 3 moles of oxygen for every 2 moles of KClO3. And then you can use the, the molar mass of the KClO3, and it's 122.55. So there's 122.55 grams of KClO3 in every 1 mole of KClO3. Again, making sure everything divides out, moles of oxygen, moles KClO3, and now I can punch this one in and solve, and I got 0.200 grams. So let me double check that one again. I have a tendency to sometimes plug things in wrong. Nope, that's what I got. And KClO3. So we found the mass of the potassium chlorate that was needed. So as you can see, sometimes you do the stoichiometry first and then the gas law problem. Other times you might start with the gas law problem and then do a stoichiometry. There's different variations, of this on WebAssign. We did not assign all of them to you. In the WebAssigns, we did not assign all of them because some of the WebAssign problems have where the gas is collected over water. When that happens, you need to account for the pressure of the water vapor at whatever the temperature of the water is. And so any answers that you do on WebAssign would be incorrect because, that is something that we're leaving as like a bonus if you wish to pursue that. That's just sort of like a challenge that you could take on. If you're planning to take AP Chem next year, you might want to, look into that Dalton's law of partial pressure and apply it to when, there's a chemical reaction and the gas is collected by bubbling it through water. But you don't have to. It's just if you are taking AP Chem next year, it is something that would be reviewed in that course and would be used in that course. So you might want to practice it. That's up to you. It depends on right now what all you've got going on. So hopefully this helped you out with putting stoichiometry and gas laws. You should be able to calculate any of these variables and always label and give your answer with, the suffix. So hopefully that helps. And good luck with everything. So. Let's